because we were discussing before class, be ready tomorrow. I don't know, is it 85 or 90 minutes? Get yourself psyched up for that. Bring your caffeine to keep you awake. There's a lot of math to do tomorrow. I know.
Because I used to do the math.
Okay, example 3. These are our 212 notes. Example 3. This function has a horizontal dilation. Would you agree with that? Yep, you put a coefficient, multiplier on x. That is a horizontal dilation by a factor of what? 1/6. Okay. Directions say, show that f can also be written as a vertical translation. So we want f of x, which is this guy right here, to be some other function plus k. Well, it's actually quite easy. The problem, it always looks so complicated, but it's really pretty easy. What do we know about, when we take the logarithm of a product? What do we know? We can split it into a sum. So wouldn't this be the log of 6 plus the log of x? And isn't the log of 6 just some number? Some constant? So we're done. Our function is log x, and our constant is log 6. Remember, vertical translation means you move it up or down, you add or subtract something. In this case, we're just taking our standard logarithm and adding log 6 to it. Vertical translation. All right, example 4. We got 2 functions. One's base 4 standard logarithm, and the other one is a base 9 standard logarithm. We're going to show that f is a vertical dilation of g by finding the value of k, so that f of x equals k times g of x. So let's just stop for a second. Vertical dilation means we multiply by something, right? So if you put a 2 out here, that stretches you vertically. So this is going to be our vertical dilation right here, okay? We got to figure this out. So just taking the given, would you agree that the log base 4 of x has to be equal to k times the log base 9 of x? Would you agree that's what's going on? And our job is to find k. It says, well, yeah, we got to figure out what k is so we know what our dilation is. So I'm going to divide. So k equals this division. Does that make sense to you? Now, what is that? That is supposed to be some constant. And the way I have it written right now, it is not a constant because it has variables in it. Okay? So, this is where I need you to back up a minute. We're kind of, those of you with new calculators are kind of at a disadvantage. Because when we have things like the log base 5 of 16, you just used your magic log base button and typed that in. What did I have to type in? I showed you. What does this equal?
Log base 5 divided by log of 16.
Log 16 divided by log 5. So top number, bottom number. So this is called the change of base formula. You guys don't really need it because you have that button, that log base button. But this is what's going on behind the scenes. Okay? So this right here equals the log of 16 over the log of 5. So I'm going to come over here. That numerator equals the log of x over the log of 4. Would you agree with that? The numerator would be log x over log 4. And then the denominator would be log x over log 9. Now, what is going to happen when I simplify this? Charlie?
You're gonna get log 9 over log 4. Because
Okay. Is log 9 divided by log 4 a number, a constant? I've done my job. I've done what I needed to do. So my job, make sure I follow directions, my job was to find the value of k, and I just did it. It's right there. This is the value of k. So
What is the 9 for the numerator?
this is a division problem. So when we divide, remember keep, change, flip, or invert and multiply. So I'm dividing by this, so I'm going to be multiplying by this. Right? Division by fractions. Right, everybody follow that? Now, notice that our answer, here was our original problem. Here's our original problem. We had log base 4 of x equal k, log base 9 of x. And k turned out to be the log of 9 over the log of 4. That will always be the case. So if you have storage capacity to memorize that, that will always be the case. But you can always work it out too, and it's pretty easy as long as you remember this. Changing this. All right, now we got a little work with natural logarithms. Natural logarithms are simply log base e. There is no difference in any of the properties. Press a different button on your calculator, but nothing changes because it's a natural logarithm. So, 3 ln x minus 4 ln y would match up with which of these things? A, B, or C? Or D? Absolutely A. What does the minus tell you? We're going to have a division. What are the coefficients out in front? What is the 3? That is an exponent on x. So it is definitely A. All right, next page. We're not going to do this whole page, but there are a couple of things I want to do. That table at the top, we're on the puzzling with properties page. That thing at the top, just so you see that this actually works. Type log 12 on your calculator, and then type log 3 plus log 4. So type log 12, get an answer, then type log 3 plus log 4, and you should get the same answer. Right? Because 12 is 4 times 3, and that means log 4 plus log 3 when we split it up. Okay, so are we good on that? That's backwards. I think, yeah. There we go. Okay. Number 6. This is an interesting question. Number 6. How could we find the value of log 30 if the 3 button, if our calculator doesn't have a 3 button? Charlie?
we give you log 5 plus log 6.
Oh, there we go. Would that work? Yeah, because 30 is 6 times 5. Easy. Number 7. A student noticed that log 1/2 gave the same result as negative log 2. Why is this? Leah?
Because the negative 1 up front becomes the power of 2.
What is 1/2? 2 to the negative first? Everybody okay with that? All right, that's enough of that page. Let's turn it over. Number 1, condense this expression. Remember that base is irrelevant as long as they're all the same. If they're not the same, we have to use our change of base formula to make them the same, but these are all the same, so we're good. We're gonna condense this into one logarithm. Now, Berto, you got an idea what might be in that parentheses where I put all this together?
Oh, yeah.
4W over 7.
What do you guys think about his idea? Perfect? Perfect. All right. Number 2B. A is just filling in the chart. Okay, that's fine. We're not going to do that. B, write an equation relating log base 2 of W and log base 8 of W. Take a second with your partner and see if you can figure out how to relate these. Log base 2 of W and log base 8 of W. Anybody have an idea? Charlie?
Well, I was thinking back to the constant equation, and I was like, why don't we just add another constant to the problem? So I did a constant problem.
So tell me what you did.
I added a coefficient to the log 2 of W side.
So put like K here or something?
Exactly, yeah.
Okay.
And so
And you said
then,
equals or something?
yes.
Okay.
And so then I did K equals log 8 of W divided by log 2 of W. And then I did what we did on the last one, log W divided by log of 8 all over log of W divided by log of 2. And then got the answer of log 2 over log 8.
Wait, just log. Over log 8. Now, did you do anything with that?
I just added it to the log of 2 side, or log 2 of W side equals log 8.
Okay, let's talk about this one, because I think you can simplify that.
You can?
I think so. Because what do I know about 8?
Well, it's divisible by 2.
Well, not only that, it's 2 cubed. So this is the log of 2 cubed.
Yeah.
And then that 3 can come out in front. So now I have log 2 over 3 log 2. That is cool. And what is that?
That would just be 1/3.
So I love your idea. So going back here, 1/3 log base 2 of W equals log base 8 of W. I personally did it the other way. So my K was over here, so I had 3 over here. But yeah, that's perfect. Are we okay with that? All right, good job. Number 3. The parent function, all right, so we're starting with the standard old logarithm. Stretch horizontally by a factor of 100. Okay, So what would that new stretched function look like? Stretched horizontally by a factor of 100. What would it look like? How would I modify this? Log by a factor of 100. What would have to be here? 1/100th x? Wouldn't that stretch me by a factor of 100? So this is my stretched function. Now, which of the choices there would match that picture? If I could graph that picture, which of my choices here would match that? Can you figure that out? Now remember, that's a multiply right there. So can I split that? So it'd be the log of 1/100 plus the log of x. So what's the log of 1/100? -2. Why is the log of 1/100 -2? Because my base is 10. So the log base 10 of 10 to the -2nd is -2. What does that do? Plus a negative, so that's like log x minus 2. What does that do? Down 2. So I think your answer is C, a vertical shift down 2. And finally, Chandler is working on this problem. Somewhere she made a mistake. Where did she make a mistake? Is the log base 2 a 32/5? Yeah, because 2 to the 5th is 32, so that's not a mistake, that's right. Where's her mistake?
On the last step, you can't just combine.
You're right, you can't add those, they're not like terms, right? You can't just add those. So yeah, that's where she made a mistake. All right, let's stop that for now. We're taking a break till January. On those notes, that homework will be due on Friday though. Make sure you get that in 2:12 p.m. Friday. I apologize, I noticed some kids have come in. When I fed the things through the copy machine, I must not have had something lined up right, because some of the bottoms got cut off. Just do your best, do your best. With that. All right. Here we go. In my constant rest to save paper. Some of these things are shrunk so much you're gonna have to read them to me probably. But here we go. So why don't we take a couple of minutes, and I wanna do whatever we need to do to help you. So take a couple minutes and maybe look at the first page, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, and read through the questions and what do we need to talk about. So take a couple minutes with your team. And what do we need to talk about? The answers, by the way, are in Canvas. So whatever we don't do together, you can do on your own and check your work. Okay, anybody find anything so far? Yeah, Alberto?
Can we do, the number 4 says, find the instant rate of change of the g of x at x equals
Okay, is this 1, 1, 1, 2, 1, 3, 1, 4, 1, 5?
the first page, right?
Yeah.
Yeah.
That
Oh, 1, 2.
over here. So,
It's over here.
okay, so see how they're numbered over here.
Oh,
Okay, so it's section 1, 2,
number 4, yeah.
number 4. All right, so section 1, 2, number 4. All right, so we got a table of values. Anybody remember how we find the instantaneous rate of change?
Once you get as close as possible.
You just keep them as close as possible. So, g of x, there it is. So g of x is negative x squared plus 4x minus 2. Right? And I want to get close to 2. So remember your average rate of change is f of b, or actually in this case, g of b minus g of a over b minus a. And we want to pick an a and a b, so here's 2. We want to pick an a and a b that are really, really close to 2. So we might do, let's say, g of 1.999, I don't know, 2.001 minus g of 1.999. That would put us within 1/1000th on each side of 2. So let's just do that. We'll need our calculator to do that. Let's see what we come up with. I got 0. Did you get 0? Oh. I actually got 0. Yeah.
Are on the table, are the top values y or the bottom values y? Because I'm just, I
Oh, wait, be careful. In the chart, that's function h.
don't. Oh.
We're using, weren't we using g? Yeah.
Yeah.
We're using g, which is this definition right here. Remember how our functions can be written as equations, they can
Yeah.
be written as charts, they
Right,
can be
yeah.
written. So this particular problem refers to function g.
Okay. Yeah, I was.
So I just plugged these numbers into that, and I might have done that wrong, but I just looked at it again. Did anybody else get 0? Now, I didn't do any rounding off, I kept everything in my calculator. Okay, so no one else is getting 0?
I got it.
Oh, you got 0? Okay, now. If, I did that really, really close. close, Alberto. So I'm pretty confident zero's what I want. But if you wanted to get even closer, you could. What I would never do is use like 1 and 3, okay? That would not be, I gotta get really, really close, okay? Next year, when you take calculus, you will learn about the first derivative. The first derivative gives the instantaneous rate of change, and that's how I knew I was right, because when I take the first derivative of that and solve it, I get 0, so, and it worked out, it gave us 0, so we're all good. We're all good. Before I forget, and I almost did, I want to give you a little bit of rundown about your semester exam. This is the actual page on the calculator free response. So your semester exam will consist of 4 pieces, just like the AP exam. You will have multiple choice calculator, multiple choice no calculator, free response calculator, and free response no calculator. And I wanted to talk about the free response calculator part, because on exam day, we're not gonna have time to go through all this. This will be there, this is like stapled to your exam of this very same thing. But I wanted to go through it with you first of all. Show all of your work. It's gonna be scored on the correctness and completeness of your responses. So what does that mean? You gotta show me what you're thinking, right? And more important than even me, when you take your AP exam, you gotta show the reader that was reading your exam, you need to show that person that you know what you're talking about. Here's how I'm getting my answer. Okay? You're expected to use your graphing calculator for the purpose of producing graphs and tables with everything, performing computations. Now, why is that statement in there? Because if you run out of time because you're doing stuff by hand that your calculator will do, too bad, so sad. You are to use your calculator to its fullest extent. So if they give you some points and say write a regression, if it's on the calculator part of the exam, use the regression feature of your calculator. Don't be doing all that work by hand. You'll run out of time. You'll probably get the right answer, but you'll run out of time. Avoid rounding intermediate computations. Okay, so in other words, if you have a multi-part computation like we just had right here, do not type this in and write it down, and then type that in and write it down, and then go back and type this in and then minus this. Don't do that. Leave everything in your calculator so there's no rounding. Got it? When they allow you to use a calculator, they want you to use it to its fullest capacity. Okay? All right. Yeah, that's what the next one is about. Use it to store information. Okay, do we know how to store on our calculator? We don't? Well, one way to store on your calculator is, so type in, do 56 divided by 2. I mean, I know we know what that is, but let's just do a computation. So 56 divided by 2. Okay? Now if I want to store that, I have a store button. Right here in the first column, I have a store button. I hit store, and then give it a name. Call it whatever you want, like A. And I did the wrong thing, so store and then alpha A. Now, that number is now stored in my calculator as A. Now, you guys with the newer calculators, can't you scroll up and grab things from earlier computations? Yeah, so you don't have to worry so much. If you have an older calculator, we can't do that. We can't scroll back up, so we have to store it. Y'all can store it. That's what that store button's for. And then just remember, okay, when I need that again, I call the A. Make a notation on your paper. This is what I called A. And then if you type in something else, you can call it B. That's okay. And then eventually you want to do A plus B, okay, just type A plus B. and it'll pull those things back out for you. All right. Show all work and record all answers in the space provided. Nothing will be graded that is not in the appropriate space. Okay. Now, I want to run through that with you one more time. Make sure you're ready for what is coming. Alright, so here's the calculator part of your exam. Alright, so if you wanna write this down, you can, just so you know what's coming ahead of you. Alright, so there are 29 multiple choice, no calculator. There are 3 no calculator free response, but get used to it, free response questions have multiple parts. Okay? And there is some choice involved in that. On one of the problems, it will say, choose one. Couple of options, you pick the one you're most comfortable with. Okay? Then on the calculator part, there are 4 questions. Okay, 4 free response calculator questions. You will read through all 4 of those quickly and choose one to do. Choose one of the 4. If you have time, and only if you have time, you will go back and choose another one to do as a bonus. All right, so you're gonna read through, they're multi-part problem. Each one of them focuses on something that's multi-part. Your answer sheet to your free response looks like this. The directions I just gave you are right there. And then part A, part B, part C. But within those 3 parts, there are sub-pieces in there. So part A might have 5 different things that you have to do, and then part B might have 5. These are big problems, that's why you're only doing one.
Do we put our work on the end sheet?
Your work goes right here where it says part A. Everything goes right here. Part B, everything goes right here. It says A, C.
So when we're done with our first question, if we wanna start on a second, do we turn that in and
Turn
get
it
another
in.
one?
That's why everything's separate. You turn it in. And this was actually the bonus page. This will be, or this is the required page. And you'll pick a problem, and you'll write down up here, this is the problem I'm doing. I'm doing problem 2. You will do problem 2. And then if you have time, you'll turn that in. The multiple choice calculator has 8 questions. And that's the exam. Okay, so 29 multiple choice and 8 multiple choice. 3 free response, no calculator. Basically 1 free response with calculator, but it's big. It's like 18 points. It's big. Okay, got it? On Zen Day, I'm not gonna explain all this again. I told you this is what it looks like, this is what the expectation is.
If you did like the cans and got the percent,
That's already in the grade book, yeah.
so that won't be like if you got a 92, it would be a 95.
That's how it works,
Is that
yeah.
how it works?
Yep, that's how it works. Yep. Okay, so, there you go. That's your exam. And no, these are not available for sale.
What order do you do the parts?
You do all of the no calculator first.
Okay, so no
Okay.
calculator
So you do multiple choice, turn it in, do the free response, turn it in, then, you'll do the calculator, multiple choice, and then you'll finish with the free response calculator, because then if you have time, you'll do the free response calculator bonus.
How specific do you get with points of inflection? Like, is it like within, like what range? If it's like
I
not,
mean, if you're estimating it,
yeah,
yeah, it will, that question will say estimate the point of inflection, and so, yeah, I mean, obviously you gotta be somewhere in the ballpark, but, yeah. If you're estimating the value from a graph, you can't, you have to have some leeway, cause you're estimating, okay? Alright, good, so we got that. Alright, so any question about that? Now, particularly those of you that have extended time accommodation and you've chosen to use that, again, no one is explaining any of this to you, alright? You know, that it's up to you, cause I won't be there. You'll have to take care of it. Okay, alright, good, we got that done. Okay, did anybody have another question that you have found from the front page of the review?
1.3, question
1.3,
three.
number 3?
Yeah.
Okay, so let's look at the tables. So this question, does deal with the tables. This is 1.3, so we have table number 1, which is 1, 2, 3, 4, and 0, 1, 4, 9. And then we have, so let's just start with that one. Describe and explain the concavity for both tables. All right, how do we know if something is concave? If we don't have the picture, how do we know if something's concave up or down?
Well, if it's going up, the y value should be increasing. If it's concave down, the y value should be
Ooh, be careful with that. That would tell me if the function was increasing or
you're right.
decreasing. When I'm dealing with concavity,
The rates of change.
I gotta look at the rate of change. Because I know that if the rate of change is increasing, I am concave up. So I have to look at the rate of change and see what's happening with them. So, I'm gonna find my rates of change. Okay, so it looks like my rate of change here is 1. Here it's 3. And here it's 5. Now, I am doing a rate of change, so I'm doing this over this. These all happen to be evenly spaced, so it works out that these are the rates of change. But remember, you're actually doing this over this. Now, what is happening to those rates of change? They are increasing. And if your rate of change is increasing, you are concave up. Now, look at those rates of change. Tell me about this function. What kind of function is that? Quadratic, absolutely. Because the rates of change are increasing by the same amount, right? They're going up by 2s. All right, let's look at the second one. The second table is 1, 2, 4, 8, and 4, 7, 10, 13. Before we go any farther, what kind of table is that describing? Logarithmic. Because what is happening to these guys? They are growing multiplicatively. And what is happening to these guys? They are growing additively. All right, let's look at the rates of change. So here we go. Our first rate of change is 3. Our next one is 3 halves. And our next one is 3/4. Everything in this problem is positive, Charlie, but that doesn't have anything to do with concavity, right?
You're right.
What is happening to those rates of change? They are going down, so this thing is concave down. And we're not surprised by that, because if we graph a regular old normal logarithm, it's concave down. I'm not saying every logarithm is concave down, but this one looks pretty normal, and it's definitely gonna be down. All right, Celeste, did that fix you up? You have to be careful here. You can imagine putting this together was quite an undertaking, and I didn't get it all right the first time, so there, the last page is an addendum, the last 2 pages, I guess. It says exam review extras, and there is an extra from 1.2. So 1.2 actually has a part 5. And it is this addendum back here. Right here. This is just vocabulary. Let's look at this addendum thing here. For 1.2, circle the appropriate word. The graph of F is positive. The rate of change of F is negative. And the rate of change of F is increasing. Why is it increasing? Because it's concave up.
Why is the rate of change negative?
Because rate of change is slope. Which way is this direction moving? Which way is this curve moving? Down. Down. All right. G. The graph of G is negative, but the graph of G is increasing. The rate of change of G is positive. The rate of change of G is decreasing. And finally, H. The graph of H is positive. The graph of H is decreasing. The rate of change is negative, and the rate of change is decreasing. Are you okay with that? That's way back a long time ago. Everybody okay? A function is positive if it's above the x-axis.
Like on the first page, in 1.4, problem 3.
1.4, let me catch up to your problem 3, okay.
Where is that point coming from? I can't find it on any of the graphs or tables or that p of x equation, like it's not a point. So I don't know.
Okay, you mean negative 1 to 1 is not a point. That's the interval, negative 1 to 1.
Oh.
So on the interval where x is negative 1 to 1, so look at your picture. Oh, wait. I guess I'm looking at H. Is the rate of change increasing or decreasing on the interval from negative 1 to 1? Well, that interval is concave down, so decreasing. Yeah, that's not a point, that's an open interval.
Okay.
All right. Anything else?
Can you do 1.41?
1.4, number 1, given this function, where does it change from increasing to decreasing? All right, so here's my function. I don't know what that looks like. It's some kind of cube thing, right? So some kind of shape, you know, like that or something. Where does it happen, not specifically, but just kind of in general terms, where does it happen that we go from being increasing to decreasing? It's gotta be a maximum, doesn't it? Isn't that the only time we go from being increasing to decreasing? We're talking about the function itself going from increasing to decreasing. So I need to find that maximum, right? So I get my calculator out, put it in, find my maximum point. So let me read the question again. Probably referring there to the x value. So when you get your maximum point, it's that number right there. So when X is 5, it goes from increasing to decreasing. Yeah, I've got calculator and no calculator problems all mixed up here. Anything else from the front page?
1.5, number 4.
4, solve this. This one, we could certainly do this on a calculator, but this one could be on the no calculator part, so let's do it with no calculator. Okay, so do you have a thought, Alberto, on how to just get started?
First, I did I got the x squared out on the first one. Like
Oh, okay, I see what you're saying.
yeah.
Let's get everything on the same side. And then, yes, we'll factor by grouping. Does that look okay to you?
Yeah.
And so we have our common factor, which is 3x plus 1, and then we have our x squared minus 9. And what do we know about x squared minus 9?
X plus 3, x minus 3.
Mhm. So now I'm gonna do a sign chart. Here's my number line. And on the number line, I'm going to have -3, -1/3, and 3, and those will be closed in dots. And now, if it's a multiple choice question, then you can do whatever you want. If it happens to be part of a free response, it will need to show your work. So pick a number less than -3, like -4. And if you put in -4, then all of your parentheses will be negative. If you put -4 in, they're all gonna be negative. When you multiply them together then, it will be negative. And negative is exactly what you want, so we know that's part of our answer. Now we know, because we've done these before, that it's going to alternate. And again, if it's multiple choice, go for it. If not, you're gonna repeat that same process. You're gonna pick a number in here and do the sign chart. But we know that our answer is gonna be -3 and -1/3. They don't, I mean, the course is still very, very new. I don't have that much experience with it. But they generally don't ask questions in pre-response that you already know the answer to. So that would probably be a multiple choice question. Does that make sense to you?
Yeah.
All right, I'm gonna stop now, and what I would ask is that before tomorrow, you look through this thing and circle some things that like, oh my gosh, we need to talk about that, because I can't remember how to do that, all right? So we have some basis of work tomorrow during our 90 minutes together. Leah's excited, I can tell.